Hey, geometry. Today we're going to do circumference and arc length. So we're going to do 11.1. The reason being is chapter 9 we don't do normally. And then chapter 10 versus chapter 11, we think that chapter 11 is a little bit more important in terms of making sure you know that before you go on to what would be Algebra 2 next year. So we're just going to talk about chapter 11 due to the fact that we don't actually have a lesson every day, like every other day, which makes it a little bit more difficult. So, 11.1, circumference and arc length. That's where we're going to start. So, 11.1, circumference and arc length. And ironically, chapter 10 is the circle chapter, but we're still going to be talking about circles in 11 and 12. So, I have to do a little prep work. What exactly is a circle? Circle, by definition, is there's a point which is called the center, and around the circle is that from the center to any point of the circle is the same distance. That, by definition, is a circle, and any definitions I tell you, I'll put in the Google post. So there's a name for the line between the center and the edge of the circle. That's the radius, so we use R for that. And if you go from edge to edge, we call that the diameter, so we'll use D for that, okay? So we got the radius and we got the diameter. We're going to talk about today circumference and arc length. So what exactly is circumference? So the outside of the circle here, if you flatten it out, there's some distance. And the outside of the circle, so like the actual distance my pen, or my marker in this case, has to draw, is called the circumference. You could also think of it as the perimeter of the shape. So the circumference is how long the outside of the circle is. And I believe the Greeks figured that out a couple of thousand years ago. And the formula for circumference is C equals 2 pi r. So the circumference equals 2 times a very special ratio. We call it pi. If you don't know what pi is, that's just a ratio between the radius and the circle. And the number we'll use for pi in future reference is 3.14, okay? So if you ever need a calculator, you could just type in 3.14. I'd rather you do that than clicking, let's say, the pi button, because we're just going to base it off this estimate. So it's 2 times pi, which is 3.14, times r, which is the radius. Another way to write this formula is circumference equals diameter pi. And diameter is a lowercase d, actually, so let me put lowercase d. Why is the diameter the same as 2 times r? Well, remember, if r is from the center to the edge, diameter is edge to edge, so it's twice as long as the radius. So you could just set it up as circumference equals diameter r. So there's a couple of questions I could ask here. First off is, what if you have a circle whose radius is 10? How big is the circumference? Okay, well, the circumference equals 2 pi r, 2 times 3.14 times 10 equals circumference. You do the math there, that should be 62.8. So the circumference is 62.8. Let's say it was 10 inches. Since this is a length for a one-dimensional length, it would be 62.8 inches, okay? No special similage. So if it was units, it would be units. If it was feet, it would be feet. So circumference is 62.8 inches. And then I could ask you a different type of question. If you know the circumference is, let's say I ask you, the circumference is going to be, I don't know, 100 feet. Give me what the radius is. So give me the radius. So if the circumference is 100 feet, find me the radius. So again, it's just plugging into the equation. 100 equals 2 pi r, because c equals 100. So what I could do is divide both sides by 2 pi, divide both sides by 2 pi, and that's going to be, okay, and that's going to be 16.025. Because we make pi 2 decimal points, we kind of want to follow that same rule of estimation. So that's going to be r equals 16.23. So 03. So r equals 16.03. And I didn't realize the glare kind of makes it hard to see there. Okay, so that's the first part of this lesson, which is circumference. Then we're going to talk about what arc length is. Okay, now we're going to talk about arc length. So as we said before, the circumference is the perimeter of this whole circle. So that's the whole thing over here. Now, if I have, let's say, 2 radii coming from the center of the circle, so let's go here and here. I'm purposely going to make it this size. Okay. Sometimes we just want to know what is the, and I'm scribbling here, but how long is this piece only? Okay. Sometimes we just want to know how long is this piece. So that little piece is called the arc length. So the little section of the circumference is called the arc length. Simple name derived from the fact that it's an arc. How long is that arc? So that's the arc length. And we have a little bit of a ratio that we're going to use to figure out what is to find the arc length. But before we do, we need a couple of our variables. So we need a radius. So the radius is always the same all around the circle. So if this is 10 feet, this would be 10 feet. If this is 5 feet, this would be 5 feet. If this is 1,000,000,000 feet, this is 1,000,000,000 feet. Remember, by definition, a circle, the radius is the same distance from no matter what direction you go. So the radius up here is going to match the radius up here. Now, we also kind of important, what is the angle in here? So we had a symbol for angle when we were doing right triangles or trigonometry. And that symbol, we're going to still use it. It's theta. Remember, it's a circle with a little line in between. So we care about the angle on the inside, which is this angle between here and here, and the radiuses, or radii, okay? So we're going to use a proportion to figure out how big the arc length is. And I'm just going to have to pause for a second to get the equation ready. Okay, so the ratio is going to be between two fractions. And so the ratio is going to be written kind of like this. Part over whole equals the part over whole. Okay, so what is part, what is whole? Okay, so we're going to do the first fraction, which is here. And we're making the equation. And after you make the equation, you could just keep it in your notebooks and use it as reference. But the equation is simply this. So, and let me get some variables here. So let's call this A. Let's call this B. All right. So, part is part of the circle. So we're looking for the arc length. So the part I am looking for, sometimes what I'm looking for, is arc length of AB. And if you want to represent an arc, it's a little curve on top. Usually if you represent a straight line, it's a straight line on top. But since we're looking for an arc, we put a little arc on top. So the arc length of arc AB. So we don't know how long that is yet. And don't worry about that. So the arc length of AB over, think about it, what from earlier the video, what is the whole circle? What is the whole circle? Well, the whole circle is circumference. So you could either put C, or you could put the actual equation right in, which is 2 pi r. Okay? So there's the arc length, and this is the on the bottom. So this is part and whole. The arc length of AB over, which is part of the circle, which is the scribbly part here, over the whole circle, which is 2 pi r. Okay? Equals. So this one, we're going to try to figure out how wide open this piece is. Because if it was like that, or if let's say the opening was like this big, let's say, it's going to change how much of the arc length is covered. So we need to know how wide open it is. So I guess let me just say this first. A full circle, and most of you might recognize this, a full circle should be 360 degrees. So if I did a 360, I technically faced back where I was facing. So a full circle is 360 degrees. Just trust me on that fact, and I feel like teaching why. And then over here, so if the full circle is 360 degrees, then the angle on the inside is going to be how big this is. So it depends on what theta is. So the part is how big theta is. And let's do a little thinking about how this looks. Look at this one. Let's say if I told you this is 90 degrees, right? All right, let me rewrite this. So let's say I told you it was 90 degrees, okay? Let's think about how that makes sense. Well, if I plug in a 90 here, it's 90 degrees over 360. Well, 90 degrees is 1/4 or 1/4 of the whole thing, and 90 over 360 becomes 1/4. So this circle up here would represent 1/4. So that matches our ratio over here. This is the whole circle, so the whole circumference. And this should be 1/4 of the whole circumference. Now, theta is what I use, but there might be another symbol, which is pretty important. It's going to be also use this. And in the textbook, I believe it says it like this. The measurement, so a little script M of arc AB. So the measurement of arc AB. So when it comes to talking about the internal angle of an arc in a circle, though you probably use this, the measurement of AB, or whatever letters are relevant. Okay? So this is your formula here. The arc length of AB over 2 pi r equals the theta, or we'll use measurement of AB. I think I'm going to use that because that's the official thing, over 360. And I'll do 2 sample problems, and I think I'm just going to post a video of some other person doing more example videos. Okay, so the equation is on my right here, and I'll just move back over here. So sometimes it will be written in words, and sometimes it will be shown in a picture. So let's find the arc length. If the measurement of AB, so that's little lowercase m, AB, is 120 degrees, and the radius is 6. So how does that look like? We have our circle here, and then 120 degrees kind of look like this. So we know the radius is 6. Since these are radiuses, I don't have to write 6 over here also. If I know it's a 6 here, I know for a fact it's a 6 here also. It says it's 120 degrees, and I said it's AB. Okay? So those are your 2 sides. And we're trying to figure out how long this is. So we're going to apply to our ratio over here. All right, arc length of AB. Well, that's what I'm looking for, so I'm just going to leave that as x. I don't know what that is yet. Now we need the circumference. So this is part of it. The arc length is x. I don't know what that is. So then we're going to show what is the whole circle circumference. So that's 2 pi times my radius, which I look back here is 6. So 2 times pi times 6 over the measurement of AB, so MAB, which they tell me right forward is 120 degrees, over the whole circle, which is always 360. This is the best part of this equation. This never changes because it's always 360 degrees. A circle is always 360 degrees. Okay? So let's plug this in. 2 times 6 is 12. 12 times 3.14 is 37.68. So that's 37.68. 37.68. And then from here, you could do your either cross multiplication. So I could do 37.66 times 180, or times 120, I'm sorry. And then 360 times x. You could do cross multiplication. You could do the butterfly method. I guess that is cross multiplication. Or you could do, some people like to go multiply diagonal, then divide by the thing. There's multiple roots, so you could simplify the fraction first. So it equals 1/3. And this equals x over 37.68. So then I just do the math. 37.68 equals 1/3. I can times 37.68 on both sides. So 37.68 divided by 1/3 is going to be 12.56. So my arc length is 12.56. So sadly we don't have a symbol for arc length. We don't have a symbol for arc length. So arc length of AB is 12.56. One more and then I'll sign off. Okay, so this last one is going to be a tricky one. Find the diameter given that the arc length is 15.7 and the measurement of AB equals 100. So you're going to look at your equation and you're like, Mr. Tobel, there's no diameter. Remember, this over here is my circumference. So I could rewrite I could use either 2 pi r, or I could use the other version of the equation, which is diameter pi. So for this question, because I'm looking for a diameter, and maybe sometimes you're given a diameter, you're going to switch it to diameter pi. So you have to be able to switch it from either 2 pi r to diameter pi. Okay, so let's plug in our numbers. So first thing, the arc length is 15.7. Oh, and I guess let me just draw it as a circle just so we have a little visual. So 100 degrees is a little bit bigger than 90. So we know this is 100 degrees. We don't know what radius is yet, or diameter also, but we don't know what either is. And then we know this length here from A to B is going to be 15.7. These letters could be anything. It could be D to F. It doesn't really matter, but that's important to know. Okay, so 15.7. So let's plug in what we know. The arc length we know is 15.7 over, we don't know what the diameter pi is yet, equals the measurement of this angle right here is MAB, so that is, we already have it, is 100 degrees, over this one, which is 360. And very nicely, that's always the same, 360. So we kind of have the situation, we have diameter times pi. So because I have two variables, I'm just going to do a cross multiplication, or a butterfly method. Okay, so on the left is going to be 100 diameter pi equals, and remember, pi is a number, so you can multiply the number whenever you want. So maybe I'll just do that right now. So that's 314 diameter equals 360 times 15.7. So 360 times 15.7, which is 5652. So that's 5652. Okay, so we have that. So then, since it's 314 times diameter equals 5652, I could divide 314 on both sides. So diameter is going to equal 314. The diameter happens to be 18 in this question. So the diameter is 18. Let's say they ask a bonus situation where what is the radius? Remember, if the radius is from the center to the edge, the diameter is all the way through, so that's twice as much. So the radius is going to be half the size of the diameter. So the radius should be 9. I did just ask for the diameter, so you'll be done here. But I just want to point out you could just cut the diameter by half, and you'll get the radius. Okay, that's the lesson. I'm going to also post a video, and I'm sorry for the camera shots because I don't know where my camera stand is. But I'm going to post this video, and I'm going to post 2 additional videos of another teacher going over it. Maybe listening to them will be a little bit more clear for you. Oh, one thing before we go off, actually. One thing before we get off. Sometimes, I think maybe somebody might have had this question. I'm sorry if I forgot this. AB, when I say arc length AB, so you're like, well, how do I know you're talking about this or the long way around? Okay? Which is a very valid question. How do I know which half you're talking about? If this is 100, so this would be 260, right? How do I know which side am I talking about? If I talk about the long way around, I need to either give you a third variable. So I have to, let's say, call this C. So if I was talking about the long way around, I would say this is the arc ACB. So this is arc starting from A past the C to B. If I just say arc AB, you want to assume it's the shortest distance. So it's going to be this one. So I have to be particular if I want you to go the long way around. Okay? And I should have put that earlier in the video, and I apologize I had to leave it to then. Okay? If you have any questions, I'll have a Zoom session for today. And hopefully I can explain a little better if you need to be explained. Otherwise, good luck on the homework and have a wonderful day.